Thanks very much, Roderick. Yeah, some very direct messages there for us to consider, so thank you for that. But I can assure you, if you live on a convergent plate boundary, you can double the global mean sea level by 2100 very, very easily, and we'll see that coming out in the literature soon. And that leads me quite nicely to our next speaker, Ben Hamlington, who will talk to us more about sea level projections and tools that he's been working with. Ben.
All right, thank you. So my background is in satellite measurements of the ocean. I'm not going to talk to you about that today. I'm going to talk to you about the somewhat murkier world of working with practitioners, trying to understand how to transition from global down to national, then to local. So I think the two presentations that preceded me were a very nice setup to what I'm going to talk about here today. So to start out, this actually came up with Jeremy yesterday. So besides the have you factored in the doomsday glacier, which is a question I get asked over and over and over again as I work with practitioners, there's two very frequently asked questions that I receive. And the first of these is, what is the range of plausible sea level rise in some future year? So Roderick already talked quite a bit about plausible and what that might mean. I think that hopefully I wasn't the one when you said you were criticized. I did ask Roderick this question at the end of a presentation he gave a couple weeks ago, what does it mean by plausible? But this is a question that becomes really important as you get closer and closer to working with practitioners, right? So my definition of plausible may mean something very different than what is plausible to a practitioner or how they're kind of filtering that information. The second question is, what is the most likely amount of sea level rise by some year in the future? Right, so it's not just the high end. So when we talk about the range of plausible sea level rise, that's where those discussions of the high end come in. But it's also questions of what's most likely. So what should I plan for, right? It's important for us to consider who answers these questions and how. So is it my job to answer these questions? Probably not. It's my job to work with practitioners to try to understand how to answer these questions and then work with them to implement into planning. All right, so I'm going to take this kind of framing here with these two questions, and I want to filter it through some recent assessment reports that I've been working on. So the starting point for all these assessments is the IPCC AR6, right? So it's what Valerie talked about. That is the foundation from here. But the parts I want to focus on today are the shift from national and then to local. And there's a large range of these national reports. I'm going to focus on two that came out after the AR6. So these are two that are focused in the United States. That's where I work and what I've been working on. So the first of these is a national level report to develop sea level scenarios. The next one is a local report focused specifically on the state of California. So we have an extra complicated situation in the United States where we can generate a national report, and then every coastal state goes and writes their own report on top of that, right? So it does lead to the possibility of things going wrong, which we've seen in the past. But I'm going to talk about this transition and how what the AR6 has done really supports that transition and allows us to give better information to decision makers. All right, another way to frame this is by reducing the set of projections or possible future pathways. So within the AR6, there were just a number of SSPs and low confidence scenarios, but each one of these encompasses a likely range, right? The probabilistic projections, they have a wide range of possible pathways. When we went down to the national level, we're trying to get to a narrower set, right? So how do we reduce this down to something that is more actionable, more useful for practitioners? And then finally, when we get to the local level, that's where we're as close to the end user as possible. We want to get to as few pathways as possible, right? So working with the practitioners, what do they really need and what can we actually give them that supports what they need? All right, so at each stage, so at each of these arrows that are up here, there's two important questions to be considered. So who is the audience? Who's actually using this information? And it's actually different in the case of the national report and the local report. And also, what are they asking for and why are they asking for it, right? So as scientists, I can go and write an assessment report. I can take what was in the AR6, condense it down to what is happening for the United States coastlines, but is that really what is needed? Or is there some additional element on top of that, some additional framing that I need to make this useful to the practitioners? And the answer is yes, that is the case. One other note here, so I did mention this, this word plausible, just to show that this idea of plausibility becomes more and more important as you get closer to the end user. I basically just took those reports. This is, the global is for Chapter 9 of the AR6. There's 5 uses of the word plausible. Within the national report, there were 11 uses, and within that local California state report, there are now 25 uses of the word plausible. So we're getting more and more feedback as we get closer to the end user to find a definition of plausible, say what that means, and then to communicate that to the end user. All right, so this is the report. So this is what I want to start with here. This is the global, it's called the Global and Regional Sea Level Rise Scenarios for the United States. I'm going to talk about what we mean by sea level rise scenarios. These are not projections, probabilistic projections. There was an element of this report that was the extreme water probabilities, so like flooding that's associated with these future projections. I'm not going to talk about that here, but this is a report that's developed by federal agencies from across the U.S., working with NOAA, JPL, Bob Kopp, whose name has come up quite a bit, also worked in this report. So there are some people outside of the federal agencies who work on these. But this is an effort to take the AR6, condense it down, and to provide something that is ultimately useful for decision makers. All right, so I said that I would say, like, who is writing this, who's it for, what's the audience, and what are they looking for? So the report authors of this, it's a long name, the Sea Level Rise and Coastal Flood Hazard Scenarios and Tool Interagency Task Force. I'm part of that task force. It was even difficult for me just to read right there. But we call ourselves the Sea Level Rise Task Force. So this is a congressionally mandated task force in the United States that comes together to produce these reports specifically. The report contains future sea level scenarios that are consistent with a risk-based framing. Okay, so these are not probabilistic projections. They're scenarios that allow you to assess risk for your particular applications. We provide most likely and also bounding type scenarios. So going back to that first question, focus on the high end. What is a plausible high end? But also what is the most likely scenario to be used for planning? The audience for this, it is local and state level practitioners. So I'm going to use the word practitioner quite a bit. I'm not going to define the word practitioner too much here. It's really someone that sits in between the science and the end user, right? Someone who's tasked with taking that information, communicating it to some ultimate end user who's going to apply or put money towards adaptation associated with that information. So you can see there the state of California would be a set of practitioners that take the report and then apply it, which I'll talk about in a second. It also serves as key technical input to the 5th National Climate Assessment, so that process is underway. It'll come out in the US later this year. And then what are they asking for? So in short, they're asking for an update to the previous report. That's fairly obvious. That's a regular thing with assessment reports. There was a report in 2017. Now we need a new report based on the updated science. The timing of this came out after the AR6. The AR6 is a natural penning point for these reports. We're not creating new science, new projections. We're leveraging what's already there. And then they're also asking for a better near-term assessment of sea level rise, right? So a lot of times we think out to 2100 to 2150, longer than that. They're asking for what we can provide in the next 20, 30 years, right? So this is a shift that I think is ongoing within the decision maker community. What can we provide on these timescales where things are a little more certain? All right, so this table here may make you cringe a little bit as experts in ice sheets, but this is a way of framing these different scenarios. So there's 5 scenarios. These are sea level rise scenarios that we create for the United States. They go from low to high, and they're defined by a target amount of global mean sea level by the year 2100. Okay, so low is 30 centimeters of sea level rise by 2100. High is 2 meters of sea level rise by 2100. I'll explain how these are formed in the next slide here, but we're really just trying to capture the plausible range. You can tell by the name they're associated with risk aversion. So your lowest scenario is associated with applications where you have low risk aversion. High scenario is something you would use in a situation where you have high risk aversion. And we also provide a new thing here. We provide trajectories of sea level rise from 2020 to 2050 using tide gauges and satellite altimetry. Right, so our records are now getting long enough. There's evidence of accelerations, at least on larger spatial scales that we can average over, that provides some information about what might be happening over the next 30 years. Right, so what is getting at that issue of what's the most likely amount of sea level rise as we go forward into the future. So this coupling between observations and models is really important. All right, so how are these scenarios formed? Okay, so sea level, there's a recent paper by Bob Kopp, again, his name's been mentioned quite a bit, but he explained some of the differences between sea level projections and sea level scenarios. So he describes sea level projections, they describe the future, while sea level scenarios guide decision making about the future. That may not be entirely clear. I'm not going to go into the detail here, but I do want to talk about how these scenarios are formed. It's critical to understand that these scenarios are built by the AR6, right? They're not something different. It's not sea level projections versus sea level scenarios. It's sea level scenarios that are built off of the foundation of these sea level projections. So the way this works, we have all the different SSPs from the AR6. We set up gates, so we determine, I'm going to use that word plausible again without really trying to define it here, but we use that word plausible to come up with the range. Looking at the AR6, what is a plausible range in the year 2100? We see which of these pathways, so again, there's thousands of pathways associated with each of these SSPs. We see which ones fit through these particular gates, and then we create our scenarios that way. Okay, so these are individual scenarios, individual pathways. There is a regional pattern associated with these. It is carried through by the AR6. So while we define by global mean sea level values, there are regional patterns associated with these. So they're a full set of regional sea level scenarios. And then one other way to look at this, so we can see which of these different SSPs fit through these gates. So here's the low scenario, high scenario. It's very simple to see that your intermediate high, and high scenarios are heavily built by that high emissions, low confidence scenario from the AR6. Right, so those three scenarios, even though we're calling intermediate 1 meter by 2100, that's actually a relatively high sea level scenario. And then these really explore the high space, whereas these are more in your kind of likely range here. Okay. I do get the question a lot, how are these named? It basically goes back a decade prior to this report. It's just built into decision-making in the United States. Actually, the military wrote a report that defined these different scenarios, and then that's just what we use. We update them. We did talk a lot about renaming them, given that intermediate here is actually a relatively high scenario, but working alongside practitioners, understanding the confusion that may cause, we again mapped into the same framing. All right. So just to go over quickly the shift from the 2017 report to the recent report. So the 2017 report actually had 6 sea level rise scenarios. So there was an extreme sea level rise scenario of 2.5 meters by 2100. Okay, this is the plot here showing those different ones. Again, the exact same definition of scenarios. The big update, one of the big updates was that based on the AR6, we eliminated the extreme scenario, right? It's actually a simple thing. If I go back to that previous slide where I show you how we build those projections or those scenarios, you simply just could not build the extreme scenario, that 2.5 meters by 2100. You just didn't have enough pathways that fit through that gate. Okay, so it was an easy decision just from a construction point of view to eliminate that, but also in terms of the plausibility and working with some of the practitioners and understanding the latest science, that decision was made to remove that extreme scenario. We did use the available observations for an independent comparison to the modeled scenarios out to 2050. That's what this is showing here. This is just for the contiguous United States. But when we take the tide gauges, extrapolate those out to 2050, not doing anything particularly complex here, it fits right in between the intermediate and intermediate high scenarios. So fitting in between that trajectory of 50 centimeters to 1 meter out to 2100. And another thing here is that the range is much narrower in 2050 than the previous report. So the range is now 21 centimeters across the low to high scenarios versus 47 centimeters before. So we have much more certain information about the near term, directly matching the requests that we got from practitioners. We did extend these scenarios out to 2150. Again, another request for those that have longer planning horizons. The large range, I think as was covered here, then starts to be really generated by the ice sheets, and that starts to expand well beyond the 30 centimeters to 2 meters that we have in 2100. One other thing, we released an application guide for practitioners. So working alongside practitioners, we took this report. It was already intended to be a step beyond the AR6 in terms of accommodating practitioners, but we took one additional step and worked alongside practitioners to co-develop an application guide to help them understand what's in the report and the science that we used. All right. So I'm going to talk next about this last step here before getting into some takeaways. So we're currently working on this California report. It's going to be out later this year. But we're taking that national framing, taking it one step further and getting it closer and closer to what the practitioners need. So in terms of the WHO, this time, there is another task force. We like our task force in the United States. So a task force of California-based scientists, and now we're working directly alongside practitioners. So we have the Ocean Science Trust and Ocean Protection Council, which are state agencies within California. This report is not generated simply by scientists. We're working alongside co-developing at the outset of the report and producing this for the needs of the state. All right, so the what here is that we're providing sea level information that's used as the basis for planning in the state of California. So there is a direct connection by law between what goes into this report and then what will go into planning for the different state agencies as we start to think about adaptation. It also provides the scientific foundation for that planning. So while we're working alongside practitioners, the foundation of the AR6 and that national report are critical to this effort. We have that kind of track that we can show that this is based on the most recent and best consensus science, and that's what we're putting into action here. So the audience for this is state agencies and localities within California. So these are the end users, right? So we're working both with practitioners, but also the end users, right? So your city manager, your city planner is actually going to take this information in the report and then put it into planning. And then what are they asking for? Very similar to before. So they're asking for an update from the previous report. In California, the focus was very heavily on the high end. Part of that is what happened in the previous report with some of the information that was in there. But there were a lot of concerns. A lot of those questions about the Doomsday Glacier come from within my own state in California. They're asking, again, for a better near-term assessment of sea level rise. So they really want to know what's going to happen over the next 20, 30 years. And they also were asking for new probabilistic projections. So that was what was in the previous report. They were asking for more of the same. And this is where I talk about that inconsistency that is persistent in the United States between what happens at the national level and what happens at the state level, right? So the state, or the national report is using scenarios, the state report is using probabilistic projections. All right, so one other note here. So going back to what was done previously in California. So in the 2017-2018 reports, there were, I guess you can already see there were two of them, right? So there was the science update and then there was a guidance update on top of that. There were 4 sets of probabilistic projections, RCP 2.6, 4.5, 8.5, plus an additional H++ scenario, so a very high-end estimate, similar to what we see with the low confidence. Then within the guidance document, they came in on top of those probabilistic projections and essentially drew boxes around columns of a table. So they said, these are the scenarios you're going to use, right? This is what Bob Kopp refers to as implicit scenario formation, right? So you have your probabilistic projections and then you form the scenarios based on some assessment of those projections. The alternative is what the national report did, where you do an explicit scenario formation. You define what those scenarios are in the front end and then you form them. All right, so this 2022 report, again, I mentioned that a big update here is that this report is going to be, the science update and the guidance is delivered in a single document. This was challenging, right? So as a scientist, I'm helping to write this report, working alongside practitioners, understanding their needs. It's a very difficult process, but one that I think leads to a better assessment that can then be used and is ultimately more useful. There's the additional focus in the near term, same as before. The high-end estimate in 2100 is lowered from 3 meters. So the estimate in 2100 that was in the previous report, the previous guidance was 10 feet of sea level rise by 2100. It is now coming down to 2 meters, again, consistent with that high scenario. Another thing, I think Jeremy mentioned this yesterday in his talk, the need to develop storylines. So working alongside the practitioners in the state, we develop storylines. So in a high scenario, a high sea level scenario, what does that look like for the coastlines of California, right? What are the impacts that you're going to see? What does that mean physically about what's happening with the ice sheets? We can write those storylines and make it that much more accessible. The guidance that's on top of this is that the intermediate scenario, so 1 meter of sea level rise by 2100 bounds the most likely amount of sea level rise. Again, 1 meter by 2100 is a little high, but if you're choosing between 50 centimeters and 1 meter, then that provides the bounding of the most likely. And then the intermediate high scenario is the plausible upper end for cases with higher risk aversion, so about 1.5 meters by 2100. If you look at if you saw that table in Roderick's presentation towards the end, 1.5 meters by 2100 is kind of consistent with what they came up with working with their practitioners. Similar assessment was made here by the state of California. We did use Roderick's paper as part of the multiple lines of evidence for defining plausibility and helping them to generate that guidance. Beyond 2100, then that's where it starts to really open up. So you start to factor in the intermediate through high and some of the uncertainty associated with that as you go forward. All right, and just to show this, last couple comparison here. So this is for 2050. I'm showing here on the left These are the sea level rise scenarios that we use within this report. These are the SSPs, and these are the previous 2017-2018 report. So this, again, is for 2050. The thing to note here, I'm not going to go over these in too much detail, how much smaller the range is in 2050 than what was in the previous report. This is 2100, again, just noting that our sea level rise scenarios are capturing most of this range within the SSP. A little bit more than that, again, you have a very high H++ scenario. And then this is going out to 2150, where I'm showing here the likely ranges associated, or the 83rd percentile associated with each of these scenarios. You really start to get this very broad expansion as you go forward. Okay, so to finish up here, some of the lessons learned, right? So the ongoing shifts in upper end estimates, so I think Roderick made this point, that if you look at kind of the medium confidence or the likely scenarios, they're pretty similar from one report to the next. The practitioners understand that, they see that. The things that are changing are the upper end estimates, really. That's the focus of a lot of the discussion here, right? What is happening to that upper end? What could happen with the Antarctic ice sheet, the Greenland ice sheet? So because of that and the need to implement adaptation strategies, there's now this greater emphasis on what's going to happen in the near term. This is not to say that the longer term is not still important, but they want information about what's going to happen out to 2050, right? What is something they can start planning to? There's something called dynamic adaptation pathways, where you start to do low cost, low regret actions in the near term and then assess and continue to monitor the science and update. That is something that is also increasing in emphasis within practitioner communities. Another lesson is that I think it's important to establish consistent pathways for producing assessment reports. So that's really what we're trying to do here. In California, we shifted from probabilistic projections to the scenario-based framing, the sea level scenario-based framing. This will allow future updates to be a little more seamless. It'll bring consistency between what's done nationally and what's done at the local level. And then the last point here, working alongside practitioners from start to finish, I think really leads to more useful end products, right? It's critical that we work with practitioners in this process, especially as we get to more local levels. Again, it can be a complicated thing, it can be difficult, but that's something that I think is increasingly important. Going back to the definition of plausibility, I obviously did not define plausibility within my talk, but I think working with practitioners and end users, that's where you can help provide a definition of plausibility that makes sense to them, that is applicable to their situation. And then also, working with practitioners allows us to develop those storylines that I think we're getting very positive response to in the state of California, will really help with the application of the scenarios. And then last point here, it can really assist in developing delivery mechanisms of the needed information. So that can mean writing better reports, it can mean writing application guides, developing online tools. Valerie showed a tool that we have on sealevel.nasa.gov to make the information in the AR6 more accessible to practitioners. All of that can be done in working alongside practitioners. And I think I'm at time, so I will leave it there. Thanks.